Video about Amazon scraping, and I thought we would take a different angle and scrape internal search suggestions. So, one thing you might notice about most e-commerce sites nowadays is you can click into the search bar and say, maybe we're looking for dog friendly something, right? Dog friendly. And then we have a lot of different options here. Now, what if we could actually scrape all these different types of dog friendly something, right? Or maybe dog friendly rugs. And what happens here for living room, round, washable? So let's build something that lets us do this. So let's open up our network tools again. Command Shift C. I'm on a Mac. Your Windows will differ here. And what's happening here is when I type something in there, they're going to make XHR or AJAX requests to some server. So in order to figure out where it's going, we need to open up the network tab. And maybe I'll click on XHR. And we'll clear everything just so we have a better view. So I'll go back here. I'll type in, oh, dog friendly. Okay, so you see all these requests going to suggestions, right? So let's actually take a look at the URL. Let me try this. Let me copy the link address. Remember last time we copied as curl and we got the header and the user agent, all sorts of crazy things to trick Amazon. But I think in this case it might be, maybe we could do it with just regular Python. So all right, so let's break it down. So we'll go back into our notebook and let's take a look at the URL. So hmm, completion Amazon 2017. That's old. We have a session ID, a customer ID, a request ID. Got a lot of stuff here. And dog FR. So prefix equals dog FR. So maybe we'll just start with dog friendly. Let's turn this into a function. Let's say define scrape Amazon autocomplete. And in here we'll take the query and then we'll build the URL. We'll say the API is equal to an F string. And in here we will dog friendly. So we'll just, that's what we need to do. It needs to be a plus. And what did I call the variable, the function argument? Query. Query. So, okay. So now let's just be really, let's just try it out. So we'll say response is equal to request.get. We'll get the API URL, and I'll still use my headers. Why not? And return response. So let's check it out. Scrape Amazon. I'll save it to sample response is equal to that, and I'll type in dog friendly. Notice in the URL it looked like that. It was like a plus the word. Let's see if we can get away without that. See if we get a 200 response. 200. Okay. What did it look like? If we look at the text property, that looks pretty good. Now, you'll notice that this is not text, it's JSON. So we need to handle the JSON, and a good place to do it might be in the function. So what you can do when you make a request to an endpoint that does return JSON, one thing we could do is just say I want JSON from it. And that works with request. So we say request, get it, and then convert it to JSON. So let's try that, make sure it works. There we go. So now what happens is it's not actually JSON, it parses the JSON into a Python dictionary. So if we look at the type of sample response, it's a dict. So let's check it out again. And there we go. So now, what is this? We have something that looks similar to what we were working with earlier, a list of dictionaries. So maybe, what are the keys that we have, right? We have keys, maybe suggestions we want to get. Let's just stare at it for a second. I want this list of dictionaries that repeats itself. So maybe I'll say suggestions. That looks good. It's a list of dictionaries there. So, well, we know we could use pandas to just parse out a list of dictionaries. So you know what? Maybe I'll make this function a little more complicated and call it, I'll scrape the autocomplete to a data frame. And I'll say that's I'll call that the JSON response. And then what I'll say is return the PD data frame from records. I'm going to pass in the JSON response at the key of suggestions. So, we're doing a lot in this function now. We're calling an API. Well, actually, we're doing a bunch of things. We're building a request. You could arguably have that in its own function. You're calling the API. That could be in its own function. And we're processing this and returning a data frame. So we're doing a lot of stuff here. Things could go wrong, but just for the sake of being expedient, getting the point across, we'll continue to do it. So now sample response, I should probably call it sample df. And guess what I've done here? I've used the old function, not the new function. So again, Jupyter Notebook development, yeah, it gets sketchy sometimes, even if you're an experienced programmer. So now let's check it out. And cool. So we have dog-friendly ice melt, dog-friendly rugs, dog-friendly salt. And okay, what if we wanted to go one level deeper? What if we wanted to go one level deeper, not recursively, purely, but in a way? So I've got my sample DF here. This is interesting, that blacklisted, spelled correctly, some other cool stuff, a reference tag. Interesting. Okay. So what if I wanted to get for each of these queries, their queries? So I wanted to get a new column in the data frame where the value of the column is going to be the call to that API. Now, it's kind of a bummer because we already configured this function to do so many things. It returns an API. I'm sorry, it returns a pandas data frame. Um, so what if we just wanted to get the list of keywords? Well, maybe I could add another, and this is how code quickly devolves into a chaotic mess. Response type is equal to df. So maybe I'll say, well, regardless, we're always going to build the URL, right? Uh, you know what? Let's not go down the road to destruction here. Let's just factor out the key pieces, right? So we should probably have another function called define. Well, what are we really doing here? If we just return the list of let's just return the list of dictionaries, right? We don't need to get fancy. We could do this data frame stuff anywhere. So I'll say that, return that. And what we're gonna do here is return a list. And I think, can I do this? A list of dictionaries. Maybe I'll say from typing import dict. So I'm trying to return a dictionary. I'm not sure. Maybe list. Now I'm going off on a bit of a tangent. There we go. Sorry, no explanation around that. Typing is a module that lets you import types to use in your kind of return type declaration here and other situations. So what is a query? It's just a string. So scrape Amazon autocomplete, and I'm just going to return JSON again. So we're going to do that. And let's make sure this is still working. This should just be a list of dictionaries, right? Sample df. Okay, great. So now all we have to do is just say, I'll call my df be equal to pd data frame from records. And really, I'll just call this records because it's going to be a list of dictionaries per our return type here and how we created the function. So bada bing, bada boom, make sure everything looks good. And yeah, we're back to a data frame. So now we can actually say, let's create a new column. And I'm going to call the column query level queries. Okay. And what I'm going to do there is I'm going to use df value map. And if you've never used pandas, what map does, let's actually just look at an example, right? So make sure I have my data frame. So df value, that's just a column. It's also known as a pandas series of the object type because it's a string. So what if I wanted to apply some function or some logic to every element in this pandas series or pandas column? Well, it's actually pretty easy to do. I could just say map. For now, let's just use a lambda function, an anonymous function. Just say x dot upper. Just uppercase it, right? And maybe let's also uppercase it and turn it into a list. Okay, so clearly that's not useful, but you see how we can access the value in the column and kind of pass it into an arbitrary function. So instead of just calling x, why don't we scrape Amazon autocomplete on x? So we'll say scrape Amazon autocomplete on x. Boom, boom, boom. Okay, so now each one is that JSON response, right? So we have this list of dictionaries, and I just want the value. I just want the value. So maybe I'll say, we'll turn into a list comprehension here, and I'll say j.get value for j in that. And yeah, so we're doing a lot here. And let's save it to another column. I'll say child queries. And we'll just set that equal to that and hope that works out. It hasn't errored out yet, so I think it'll actually work. And then we'll look at the head of the data frame there. And here we go. So let's analyze it. Let's just look at the columns value and child queries. So df value child queries. So you have the root term dog-friendly ice melt and child queries. Now for dog-friendly ice melt, that would be pretty extreme if they had like modifier suggestions for that. But dog-friendly rugs for living room, so on and so forth. So yeah, that's kind of an interesting way to like go from one level of dog-friendly to the next level. So this is like the variations on the first level of dog-friendly, this column. And then we call the function again and return the child queries. And if this looks a little bit bizarre, try to break it down. We're just taking a column and we're mapping it to a function. And the function is an anonymous function, lambda x. And for the most part, what is x? It's just the value in this column. And what do we want to do with that? Well, we want to call our scrape Amazon autocomplete function on x, and that's going to return a list of dictionaries. And we're going to iterate over that list of dictionaries with a list comprehension, and we're going to use j. I could have used whatever. And since j is a dictionary, because this whole thing returns a list of dictionaries, that's why we're using a list comprehension. We want to get the thing at the key value, which corresponds to the suggested query. So that is kind of a cool way to get a input value in child queries. And what if we wanted to like print this out or make a CSV, right? Well, here's a kind of silly way we could say for index row in df dot iterows. Did I get that right? Did I spell iterows right? I don't think so. No, I think it's one T. Okay. So the index and the row, I'm going to say original query. Well, let's just say print row dot value, and I'm going to use the brackets here in case value has like some overloaded embedded meaning. And what I'll also do is now I'll say, yeah, so what I'll do is for next row, in row at child queries, let's print out row value, row, well, next row. There we go. And maybe we'll turn it into an F string here. And of course, if it's an F string, we need to put the dynamic piece just like that. And instead of a comma, maybe I'll just put a little arrow indicating that that root query gives way to these other queries. So, you could use that, you could write it out to a CSV file. Maybe we could say with open output file .txt, and we're going to write to it as f, and then we'll do our iteration. We'll say f.write, and maybe put a new line. We'll find out if it worked. And now we'll say cat output file.txt, And that actually worked. Okay, so yeah, just in case you didn't know how to go from that kind of embedded format. And by the way, in pandas, this is a list. A value of a column could be a Python list. It's not just a string that looks like a list. It's actually, like if you look at the first row, you can see like child queries. If you look at the type, should just say a list, right? So nothing fancy there. You can have a list as a value in a data frame column, no biggie. So yeah, hopefully that was useful. Now you can kind of mine keywords on Amazon and perhaps get away with it at some scale. But it could be useful for product discovery, for sort of seeing how often things change. For instance, if you got a set of 1,000 keywords that represented consumer behavior, how often would these queries change? What new modifiers might you find? Would that be a possible way to source, new products or get ahead of the curve? I don't know. Everything is crazy and competitive. Writing the code is always the easy part. Doing things is much, much harder in the real world. Alrighty, y'all. See ya.